The speeds in miles per hour of 6 randomly selected qualifiers for the Indianapolis 500 in 2012 are listed below. Estimate the mean qualifying speeds with 90% confidence. Round your answers to 4 decimal places. So always go to your question what you're being asked for. Here you're being asked to estimate the mean qualifying speed with 90% confidence. So first we'll go ahead and write down our formula for calculating confidence intervals. So we've got x minus our t-value times the standard error, which is sample standard deviation divided by square root of n. And that's going to be less than the mean, which is going to be less than x bar plus t-value times the standard error. And in this case, we know that we're using the standard error s because we have a sample here. So we have this randomly selected qualifiers. So in order to find our confidence interval, we're going to need to find the mean of these 6 sample observations. We're also going to need to find our t-value and our sample standard deviation s. The only thing we know so far is n, which is 6 because we have 6 observations. So let's go ahead and find our sample mean and sample standard deviation in our calculator. So in order to calculate our sample mean and sample standard deviation, when we have individual data from the sample like we have here, we'll go to Stat, and then the Edit menu, and select Item 1, which is Edit, and we're going to need to edit that list. This is information from a previous problem, so we'll scroll up to highlight L1 and select Clear and Enter, and that clears the list for us. So now we'll go ahead and enter in our observations, which were 223.422, enter, 223.684, enter, 224.037, enter, 225.172, enter, 226.240, enter, 226.484, enter. So now we have all of our observations in the list, so we'll select Stat again. And now we want to calculate, so we'll go to the Calculate menu and select Item 1, which is 1 var stats. And then we'll select Enter, and we end up with a mean of 224.84. And a sample standard deviation, it's the 4th item. Remember that a sample standard deviation is denoted with an S. So that is 1.323 or 1.324 if we round to the 4th decimal, like it asked us to do in the problem. So as we saw in the calculator, our sample mean is 224.8398, and our sample standard deviation is 1.3240. So now we have our mean, we have our sample standard deviation, we know n. The only thing that we're missing is our t-value. And we know that our t-value comes from the t-table. We can also calculate it in our calculator, so we'll do both here. We know that we first need the degrees of freedom, and we know that degrees of freedom for a t-distribution is n minus 1, so that's going to be 6 minus 1, so our degrees of freedom are going to be 5. And then we'll go look at our t-table and we'll look for where the 90% confidence interval intersects with 5 degrees of freedom. This is our student's t-table, and we're going to go ahead and look at just the first part of the table because our degrees of freedom are small here. So the problem tells us that we're looking at a 90% confidence interval, so we're going to look at the column that has 90% as the heading. And then our degrees of freedom here are 5 because our number of observations is 6. So we know degrees of freedom is n minus 1, 6 minus 1 is 5. So where that row and column intersect, we get a t-value of 2.015. So that's what we're going to use in our formula to find the confidence interval. And so we end up with a t-value of 2.015 as you saw on your t-table. So I'll also show you how to calculate the t-value in your calculator instead of using the t-tables. So first you'll have to imagine the t-distribution in your mind, and remember that it approximates the normal distribution. So you can also think of the normal distribution. You're looking for the 90% confidence interval, so the middle 90%. And if you're looking for the middle 90%, then there's 5% on each tail. 5% on the left tail, 5% on the right tail. So to find the t-value for the top of the 90%, remember that that includes the bottom 5% on the left tail and the middle 90%. So that's 95% total. So we'll go over to second distribution or second vars, and we'll select item 4, which is inverse t-distribution. And now it asks us for the probability here. And here's where we'll enter in the 0.95. So remember the middle 90% and the bottom 5%, which is the left 5%. So the 5% on the left tail and the middle 90% of the distribution. Then comma, and then our degrees of freedom, which we have 6 observations here. So our degrees of freedom for a t-distribution are n minus 1. So 6 minus 1 is 5. Close the parenthesis, and that gives us a t-value of 2.015, which is the same thing that we got from our t-table, or t-distribution table. So now we have our t-value, we have everything we need for our formula for finding our confidence interval boundaries, so let's go ahead and do that. So we'll plug everything in. On the left-hand side, we've got 224.8398 minus our t-value of 2.015 times our sample standard deviation of 1.324 divided by the square root of our sample mean, which is 6. And on the right-hand side, we have the same thing, we're just adding now. So 224.8398 plus 2.015 times 1.324 divided by our square root of 6. So we'll start with our parentheses on the left-hand side. 1.324 divided by the square root of 6 comes to 0.5405. And what we have on the left-hand side, we also have on the right-hand side, except on the right-hand side we're adding. So now on the left-hand side, we'll multiply that 0.5405 by 2.015, and we end up with 1.0891. And on the right-hand side, it's going to be the same, except we're now adding the 1.0891. So on the left-hand side, we end up with 223.7507. And on the right-hand side, we end up with 225.9289. So those are our lower and upper boundaries for our 90% confidence interval for this data of 6 observations. And now I'll show you how to do the whole thing in your calculator. To do everything in our calculator, we'll go to Stats first, and then the Edit menu, and select item 1, which is Edit, and you would have to put all of your data in here, which we've already done. So since we've already done that, we'll quit, and we'll select Stats again, but now we'll go over to Tests, and we'll select item 8, which is the t-interval, and you may have to scroll down on your calculator to find it. Once we select item 8, our stats are highlighted here, so we can do it with stats, but we can also do it with data. So let's try it with stats first, since that's already highlighted here. So our x bar, or our sample mean, is 224.8398. So we'll enter that here. We'll go down to our sample standard deviation, which is 1.3240. And n is going to be 6, that's our number of observations. And our confidence interval level is 90%. That's what the problem asked us for. We'll go down to calculate and enter, and we end up with a lower bound of 223.75 and an upper bound of 225.92.89. And the problem does ask you to round to 4 decimals, so I guess our lower bound would be 223.7506. If you wanted to do it with the data and get the exact numbers, again, go to Stats. In the Test menu, you would still select item 8, t-interval, and we now want to use the data. So we select data up here, and the list it has by default is L1, which is where our data is. The frequency is 1, so each observation happened once, and the confidence level interval is already filled in for us as 90%, which is what we need. So we'll go down to calculate, and again we end up with a lower bound of 223.7506 and an upper bound of 225.9290. So that's a little bit different, but that's just the rounding error that the other calculations had when we were just using our sample mean and sample standard deviation that we rounded.